So now that we have a better idea of what an air mass is, we need to talk about how they can interact with each other when they're moving across the globe. When we're looking at these air masses, we're going to see that the boundaries or the fronts of these air masses are going to interact with each other. And the way that they're going to interact is going to be determined by the densities of these different air masses. The density of these different air masses is going to be important, and density is going to be related a lot to temperature. Remember that when things are warm, they're going to try to spread out, becoming less dense. But when things are cold, they're going to compact, becoming more dense. So when we look at our air masses, when we have warmer air, it's going to be less dense, and it's going to rise. It'll be aloft or above the surface. But if we have cooler air, it's going to contract, becoming denser, and it's going to try to sink and move along the surface, acting kind of like a wedge. We're going to discuss 4 different types of fronts. We'll have warm fronts, cold fronts, stationary fronts, and occluded fronts. But we're going to start off with our warm front. And this is where we have a warm air mass that's moving into an area and replacing the cooler air. Because warm air is less dense than cooler air, it's going to rise above the cooler air that it's moving in and replacing. But as it's moving above this cooler air, it's going to have a relatively gentle slope. And very close to the beginning of the front, which is shown in red semicircles, where the circles are pointed in the direction that warm air is moving, we're going to see that the clouds are lower, closer to the edge of this warm air front. But as the warm air moves up this gentle slope above the cooler air beneath it, it's going to move very slowly. And as it slowly moves, it's going to release some light, maybe some moderate precipitation. So some rain, but not intense rain. Our second type of front is our cold front. In this case, we have a cold air mass that's moving in and replacing warm air. With this, the edge of our front is going to be shown by blue triangles. And again, it's going to be pointing towards the direction that air front is moving. With our cold fronts, these are going to be a lot different than our warm fronts. Obviously, a difference in the air temperature. With a cold front, it's cold air moving in. But as that cold air moves in, it's going to be replacing the warm air. And it's creating a very steep boundary between these 2 different air masses. And because the air is going to be forced up this very steep gradient, it's going to change the temperature of that air very quickly, leading to some weather that's usually pretty violent. So with these cold fronts, we typically have a lot of precipitation in a really short period of time. So this is where we're going to get absolute storms moving through instead of just a light shower. But once the actual front or the edge of that air mass moves through, the rest of the weather behind the front, it's just going to be cold weather brought on by that cold air, where it's going to be subsiding or sinking air, and therefore it's going to be dry, clear conditions. Our third type of front is a stationary front. As the name suggests, with stationary, here this front doesn't seem like it's moving at all. And that's because the airflow is moving parallel instead of perpendicular to the front. So it's stationary, it's just remaining in one position. But our last type is called an occluded front. And remember that our cold air masses move more quickly than our warm air mass does. So with an occluded front, we have a cold air front moving through. And because it moves faster than a warm air front, it's going to be able to wedge or kind of force that warm air upwards. And eventually that cold air front is going to push all the warm air upwards. And again, because it's moving faster, it can catch up to another cold air front. So with this occluded front, this is the most complex weather that we have. We're going to get precipitation in some form, because we're forcing all of that warm air higher, where it's going to quickly get colder and release all of that moisture as precipitation.